All right, let's talk about something that drives every single cloud engineer crazy, those mysterious network slowdowns. Today, we're doing a deep dive into Amazon Cloudatch Network Flow Monitor, a tool designed to finally give you some clear answers. If you've ever wasted hours or even days trying to figure out if the problem is your code or something on the AWS network, well, you're going to want to stick around for this.
So, here's how we're going to break it all down. First, we'll talk about the core issue, that lack of network visibility. Then, we'll introduce the tool itself. After that, we'll peek under the hood to see how it works, learn how to turn all that data into action, and finally, we'll walk through the first steps to get you up and running. Let's get right into it. Okay, first things first. Let's really set the stage and talk about the core problem here. It's a situation every one of us who works in the cloud absolutely dreads. A performance alert goes off, and suddenly you're faced with a really tough question.
And that question is this: your app is slow, but why? Is it a bug in the code you just pushed? Is the EC2 instance itself just completely overloaded? Or, and this is the frustrating one, is it something happening in the underlying AWS network, something totally outside of your control? That uncertainty, that's the real killer.
And that's really the heart of it, right? The cloud is amazing, but let's be honest, the network can often feel like a total black box. Figuring out if that latency or packet loss is coming from your own stuff or from the infrastructure has just been this massive headache. It's exactly like trying to find a needle in a haystack while you're blindfolded.
So, how do we get that blindfold off? Well, that brings us right to our main topic, Network Flow Monitor. It's a tool built specifically to give you that clarity you've been missing.
So, in a nutshell, what is this thing? Cloudatch Network Flow Monitor gives you almost real-time visibility into how your network is performing. And it does this by using these small, lightweight software agents you put on your instances. Now, the keywords there are lightweight, which means it's not going to slow your apps down, and near real-time, which means you get the data fast enough to actually do something about a problem while it's happening. Okay, so what do you actually get out of this? For starters, you get the most critical metrics. We're talking latency and packet loss, and you get them fast. And this isn't just for traffic between your own instances. You can see performance to super important services like S3 and DynamoDB, or even see how things look when you're going across different AWS regions. But really, it all boils down to one huge benefit. It helps you finally, definitively answer that question, is the problem me, or is it AWS?
That all sounds great in theory, but how does it really work? Let's pop the hood and take a look at the mechanics.
The whole system is built on a really simple but super powerful idea. It all starts when you deploy these tiny little network detectives inside your own environment. We call them agents.
So what is this agent? It's just a small piece of software that you install on your EC2 instances or in your Kubernetes cluster. Now, the really cool part is how it gets its information. It uses a modern Linux technology called eBPF, which lets it safely watch network stats right from the kernel. This is super efficient, but more importantly, and this is crucial, it does all this without ever looking at the actual data in your network packets. Your data stays completely private. Then, it just bundles up those stats and sends them off to Cloudatch every 30 seconds or so.
And what kind of stats are we talking about here? It's the absolute essentials for network health. You get TCP round-trip time, which is basically your latency. You get TCP retransmissions, a dead giveaway that packets are getting lost somewhere. You get retransmission timeouts, which points to a more serious connection issue. And of course, you see how much data is being transferred. Put these four together, and you get a really clear picture of what's going on. Okay, so we're collecting all this great data. But data is just noise if you can't make sense of it, right? So how do we go from all these numbers to actual decisions? This is where the tool really starts to shine.
Network Flow Monitor gives you two fantastic ways to look at your data. I like to think of it as the 30,000-foot view versus the microscope. On the left, you've got workload insights. This is your big picture satellite view. It pulls in data from all your agents and automatically flags the top contributors. You know, the connections with the highest latency or packet loss. It's perfect for spotting potential trouble spots at a glance. Then on the right, you have monitors. This is your microscope. Once you spot something interesting in workload insights, you can create a monitor to do a deep dive on that one specific connection and track it super closely over time.
Now, to make all this even easier to understand, the service automatically sorts your network traffic into these neat little categories. You can instantly see traffic that's staying inside one availability zone, traffic going between AZs, between VPCs, or even traffic that's headed for another AWS region entirely. And what's incredibly helpful, it specifically calls out traffic going to key services like S3 and DynamoDB.
And this right here brings us to what I think is the absolute killer feature, the Network Health Indicator, or NHI.
For any connection that you're tracking with a monitor, AWS gives you a dead simple binary value. It's either healthy or it's degraded. And when it says degraded, that is AWS officially telling you, yep, we see a network issue on our side that's affecting this connection.
I mean, this quote from the documentation just nails it. The NHI lets you decide instantly where to focus your energy. If your app is slow, but the NHI says healthy, the problem is probably in your stack. But if that thing flips to degraded, you can stop pulling your hair out debugging your own code and know with confidence that the issue is on the AWS network. This feature alone ends the blame game.
Okay, let's say you're sold. You want to give this a shot. What do you do? Where do you even begin? Let's quickly walk through the steps to get this up and running in your own environment. The good news is, getting started is surprisingly simple. Step 1. You just have to initialize the service in the Cloudatch console. It's a one-time click to set up the permissions. Step 2. You deploy those lightweight agents. You can do this easily with AWS Systems Manager, or if you're on Kubernetes, just deploy it as a daemon set. Step 3. Wait about 20 minutes for data to roll in, then check out the Workload Insights tab. Step 4. When you see something you want to investigate, create a monitor to zoom in. And finally, Step 5. Just make it a habit. Check in on your data regularly so you can stay ahead of problems.
You know, when you zoom out, this whole thing is really about making a fundamental shift in how you work. It's about moving away from being reactive, frantically putting out fires when everything is already broken, and becoming proactive. When you have this kind of data, you can understand what your network's normal baseline looks like and spot issues long before they ever affect your users.
So, I'll leave you with this question. It's not if you have network mysteries hiding in your cloud environment. It's which ones are you going to solve first, now that you have the right tool for the job. Thanks for tuning in.